organize 6 outside scientists who have. It appears that the rocks at Meridiani were not just altered or modified by water, they were actually formed in water, perhaps a shallow, salty sea. This is a profound discovery. It has profound implications for astrobiology. And I'd like to say, if you have an interest in searching for fossils on Mars, this is the first place you want to go.
Now, it's kind of fuzzy because we're 4.5 meters back, but this was the PanCam image that drew us, or that there are basically no parallel lines here. Everything, you can see these blue lines that represent distinctly different ripples that in separate events move past.
Is we have found what I believe to be strong evidence that the rocks themselves are sediments that were laid down in liquid water. It's a fundamental distinction. It's like the difference between water you can draw from a well and water you can swim in. Okay, so this is a fundamentally different sort of environment that we're talking about here. Settle out to form very flat, uniform, horizontal layers. Now, why is this finding important? I think it's important for 2 reasons. First of all, this was, if we're correct in our interpretation, this was a habitable environment on Mars. This was a shallow sea. These rocks are, it's a salt flat, okay? These are the kinds of environments that are very suitable for life. Now, we don't know the life was there, but we have an environment that would have been suitable for life. The second reason it's important is the potential for preservation of evidence. If you have liquid water and you precipitate minerals from liquid water, that process of precipitation, which can be very rapid, can actually trap inside the crystals, inside the mineral grains that are grown, whatever is in the water.
Avalanches in front into the dark areas and creates the cross-bedding that we see. And through the experiments that have been done here on Earth and the natural environments that we can observe here on Earth, we feel very confident that this adds up to a story about ripples moving in water rather than in wind at velocities of maybe 10 to 50 centimeters per second, something like that, maybe a mile an hour, gentle flows moving by, something like that, a set of inclined layers. But if you look at the cross-section on the lower left-hand side, you see a bunch of smiles, upward concave surfaces. This is the key attribute of that highly sinuous crest line that characterizes the types of ripples that form in water.
They show these same trough-shaped sets of cross-lamination that we've been